Well, good afternoon, everyone. Thank you for coming to listen this presentation. I guess we all here because we all interested in some level to find new ways and new tools to address the uncontrolled growth of dog population and cat populations as well. In the case of dogs, the uncontrolled growth of dog populations can have several negative consequences for both humans and dogs. And we're all pretty familiar with, some of these negative consequences. However, this problem is very complex and difficult to solve. On one hand, we have dogs and their biology. On the other hand, we have humans and their behaviors and attitudes toward dogs. And then in between, we have this complicated relationship between these two species. Computer simulation modeling can be a powerful tool that can help us better understand the population dynamics of dogs, as well as to evaluate different interventions for dog population control. But what are computer simulation models? Consider we have a complex problem that we're trying to solve. Experimenting to find a solution can be very costly or just not feasible. So what we can do? We can build a model to replicate the problem into a virtual environment. A model is a simple representation of the problem that can be used to test solutions through simulation. Once we find the best solution, then this optimal solution can be implemented into the real problem to solve it. There are several approaches regarding either mathematical or computer simulation modeling, and individual-based model is one of them. Individual-based model consists of a collection of autonomous individuals that have distinct dynamic behavior. These individuals in the model can interact with each other as well as with the environment that they share. Controlling the growth population of owned dogs in Mexico is very important for the sustainability of the rabies subsidized vaccination program. In an effort to control the rising cost of this program, in 1994, the Ministry of Health implemented a subsidized surgical sterilization program. The main objective of this sterilization program was to reduce the number of vaccine doses that will need to be administered over time. Villa de Tezontepec is a small semi-urban community located in the state of Hidalgo in central eastern Mexico with a population around 12,000 people. This location was selected as a case study to build a model. There were two reasons mainly why it was selected. One is because they have this routine spay and neuter program going on, as well as they also have a large population of free-roaming dogs. These are some of the characteristics of the owned dog population in this community. The mean age of owned dogs was almost 3 years. The sex ratio favored male dogs. More than half of the owned dogs were allowed to roam free. And some of the dogs had been spay and neuter, most of them during the subsidized spay and neuter clinics. So this is the method that we use. We build a stochastic individual-based model to replicate the population of owned dogs in Villa de Tezontepec. To parameterize the model, we use data that we collected from this location, as well as peer-reviewed literature where local data was not available. The model was run for a period of 20 years, and each intervention scenario that we evaluated was run 1,000 times. The primary outcome of interest was the final population size after 20 years, and this was basically estimated over the 1,000 simulations that were run for each scenario. This is the chart that describes the life cycle for male dogs in the model. Dogs started in a puppy state, and after a period of time, they transitioned to a young state. Once female dogs reached their sexual maturity, they enter into the reproductive state, and they remain reproductive. There were two reasons why dogs will move into a dead state. If they die from old age, as well as if they die from other reasons not related to old age, such as sickness or accidents. Male dogs in the model could also transition to a neuter state from both the young and adult state if they were sterilized in the model. This virtual population of dogs was assumed to be open with immigration and emigration. Immigration represented own dogs who were acquired from outside the population area, and emigration represented those own dogs who were given away outside the population area. This is the state chart of the life cycle for female dogs. It's very similar to the one that for male dogs. The main difference resides in the adult state. When female dogs reach their sexual maturity, they enter the in-heat state. From the in-heat state, they could transition to the pregnant state if they got pregnant, and if they didn't get pregnant, they transition to the not in-heat state. From the pregnant state, after a gestation period, female dogs transition to the not in heat state, and 4 new dogs were added to the population, 2 females and 2 males. From the not in heat state, female dogs transition back to the in heat state after a time to a new proestrus. We use the model to examine 4 different surgical sterilization interventions. These interventions vary in the way dogs were targeted for sterilization based on sex or based on age, as well as the level of surgical capacity used, specifically the number of surgeries performed per month. So dogs in the models could be targeted or were targeted for sterilizations based on sex in 2 categories. Mixed sex included both male and female dogs, and then we also have a category for female dogs only. And based on sex, we also, they were 2 categories: mixed age, which included both sexually mature and sexually immature dogs, and a young age category, which included only sexually immature dogs. We examined 3 levels of surgical capacity: 21, 42, and 84 surgeries per month. So basically, we double and quadruple the number of surgeries. Currently, the Ministry of Health in this community uses a mixed sex, mixed age approach, which means that when they have a spay and neuter clinic, they welcome both female and male dogs of any age. And they perform on average 21 surgeries per month. This is the projections of the final population size after 20 years that resulted from the interventions that we evaluated using the model. The results are presented in standard box plots. Each box represents the distribution of the 1,000 simulations run for each scenario. The center line or horizontal line inside the box represents the median, and the whiskers or the horizontal lines outside the box represent the minimum and maximum values without outliers. In the horizontal axis, we have the 3 levels of surgical capacity from 21, 42, and 84 surgeries per month. And on the vertical capacity and on the vertical axis, we have the percent reduction in population size compared to the base case scenario. The base case scenario in the model is the scenario absent of surgical sterilization. We also added in the model a community capacity to limit the exponential growth of the on-dog population, and that's represented there. I just forgot to mention the base case scenario is set at 0% in the graph. So these are the results for the interventions that target both female and male dogs. In panel A, we have the impact of mixed-sex, mixed-age sterilization after 20 years at the 3 levels of surgical capacity. And on panel B, we have the impact of mixed-sex, young-age sterilization after 20 years also at the 3 levels of surgical capacity. We notice that when sterilization in the model, we notice that as the number of surgeries per month increases, the median population size decreases. And I guess that's something that we would expect. And this is more noticeable in panel A than in panel B. So, increasing the number of resources or the number of surgeries per month is something that might not be feasible or sustainable in the long term for a single region. For that reason, let's just focus our attention to the lowest level of surgical capacity, which is the same surgical capacity used by the Ministry of Health in this location. So we notice in panel A that when in the model we target both female and male dogs of any age, only a small median reduction in population size was projected. Roughly, you can see that it's probably less than 5% if we use the graph to measure that. In contrast, in panel B, we notice that when surgical sterilization in the model target exclusively young animals, then a larger reduction in median population size was projected compared to the base case scenario. This indicates that a surgical sterilization program for own dogs, if they were to target dogs before they reach their sexual maturity, they could have a higher impact at reducing the population size over time. These are the results for the interventions that target female dogs only. In panel C, we have the impact of female-only mixed-age sterilization after 20 years, and on panel D, we have the impact of female-only young-age sterilization also after 20 years. We notice in both panel C and D that when surgical sterilization in the model target exclusively female dogs regardless of their age, a considerable population size reduction was projected. Again, this suggests that if a surgical sterilization program for own dogs were to target females only, they could have a higher impact at reducing the population size over time. And lastly, from the 4 interventions that we evaluated, the one that yielded the highest reduction in population size was the one that targeted female dogs before they reach their sexual maturity. This suggests that if the Ministry of Health of this location were to focus their sterilization efforts at female dogs before they reach their sexual maturity, they could improve the efficacy potentially of their program without having to invest in additional resources. In conclusion, I just want to leave you with these 3 main points. One is that computer simulation models are a really powerful tool that can help optimize the resources of dog management program. But beyond that, computer simulation models can be used can be applied to many things to help us better understand the dog population problems and dynamics. We can explore the possibility to evaluate non-surgical sterilization, for example. We can also include decisions making by owners. And it's definitely a powerful tool that I think, if we should consider. And if we're going to take advantage of this powerful tool, it is important that it's informed with current and robust estimates of dog population numbers and attributes. And lastly, the model suggests that the sterilization of sexually immature female-owned dogs could reduce the population, the owned dog population size over time. If you want to know more about the model and the results that that resulted from the model, you can read our article in +1. I want to acknowledge and thank the sponsors and collaborators. Thank you for listening.
Clarification today. You have made the assumption that the puppies are 2 and 2, correct? Are we interested to understand why would you not take 1.4 to 1, which was the existing attributes of the available population? I'm just curious to understand because the conclusion seemed to be pitched against young female dogs.
Yeah, so we collected the information from this location, and as we asked about the number of puppies that were born in each, I forgot the word in English now, but each litter, the litter size was about four dogs, and it was actually pretty even, like 50 and 50%. So we used that as in the model to parameterize that.
Thank you.
You're welcome.
I think we have time for one more if there's anyone. Roger?
Just one real quick. I didn't hear what the total population size was, and then getting back to kind of that litter, I think it would be more powerful. Sorry. I didn't hear what your total population size was to get a judgment on how much 21 surgeries a month represented of the total population.
Yeah, so it's about 3,000. I'm going to just maybe move to this slide. So it's about, it's not combined, but it's about 3,000, almost 3,000 dogs. That was the,
Gotcha.
The estimate population size in this location.
And then I think it would be really cool if you, on your litter size, put that in as a random sampled variable rather than just fixing it at 2 and 2. Put it in as a probability so that sometimes you're going to get 3 females, sometimes you're going to get 1, and see what that sensitivity is in your model. And I think that'll give you a good idea of kind of the robustness of your model and how sensitive it is to those litter sizes.
Yeah, thank you. Yeah, we put some distribution for different parameters, but specifically for the litter size, we just use that. So thank you. That's a good thing to consider and explore further.
Great. To stay on time, we should probably move on. Thank you, Liz.